Hello, good afternoon. Thank you so much for staying all day long with us, as I know that was a long day, and I do my best to share a little bit about machine learning at the edge. And you might be wondering, what's machine learning at the edge? Think about the link between the real world, the physical world, with the digital world. My name is Coqueiro. I'm responsible for the Solutions Architect team here in Amazon Web Services, responsible for customers and government, healthcare, education, and non-profit organizations in their journey to the cloud. And today, I'd like to show you the art of possible on those kind of technology. Show you not only with examples from other customers, how they did it using machine learning at the edge, but also building things. I really like to provide you a real experience how you can build things by your own in order to deploy it in your company, your government agency. Let's start. And I know when you think about machine learning at the edge, it sounds like vague, and I understand that. And the best way to explain it is using some examples about how others have been doing. And I'd like to start with an example from Amazon. Amazon has been working with machine learning for about 20 years. And one of our critical business is about retail, or how we organize our warehouse. So then you have an idea about how can we improve our business process, taking machine learning, and help us with our distribution center. And now I'd like to show a video about how we implement machine learning there. It's a video of one of Amazon fulfillments with our robots. Kiva, now Amazon Robotics, that helps us to bring box from one side for another side. I know that for a human, it's not super smart, but you think about scale, it's critically important, because you see robots take decisions about moving forward, turn, bringing products from one side to another side, is where the technology is at this moment. You see, in this case, those robots, they have sensors to identify where people is, identify some obstacles. And then after those obstacles, we are able to combine other kinds of machine learning technology, like computer vision. So how we can use computer vision in this context? We have the bins. We have the bins. And those bins are there, and the idea is take the image and identify if the bin is full or not. As you can see, we are combining different algorithms, different machine learning technology to help, not only in terms of movement, but also identify, is the bin full or not? It's a great example because you train all the models in the cloud and push it to the edge in order to take decisions, to know or to answer business questions like that. And definitely, Amazon is not the only one who has been working on it. So we have, it's just a small fraction of customers who has been implementing machine learning nowadays using AWS. But I'd like to dive a little bit more in terms of possibilities. And the first one, some example that you saw this morning in the keynote. It's about Formula One. Formula One is a great customer of AWS. And here, the major point is, instead of taking actions in the edge, as you saw in our robots, here we're using the car machine to take information. And then take information help, first, the driver to take decisions better. Second, the team to see where it can improve performance. And third, the audience, or all the car racer fans around the world, see the statistics, and then see who has the biggest chance to win. You see, in that case, I use the edge to collect information to process in the cloud. And maybe you are wondering, okay, Amazon Distribution Center, great project in terms of scale. They have a lot of resources, Formula One as well. But maybe my government agency don't have all the resources in the world. Or maybe I don't have all that money. Or maybe it's just too complex. Or maybe those things works in UK, Europe, US, but what about Canada? So I'd like to bring one example which answers all these questions at once. And this question about BCIT is one of our customers in British Columbia. They see machine learning as an opportunity, and then they implement with just one person. And instead of having me talking about it, let the customer talk by his own.
Hi, my name is Michelle Wen, and I'm a computer science student at the British Columbia Institute of Technology. Today, I'd like to showcase an Alexa skill that I have built for the School of Nursing. Alexa, open lab results.
Welcome to the lab results skill. Use this skill to obtain a patient's blood work or diagnostic reports. How can I help you?
Get me patient 1.
Thank you. I have found the results for patient number 1, Simon from January 22, 2018.
Switch to diagnostic reports.
What type of diagnostic test would you like?
Radiology.
Technically difficult exam done by portable. Good expansion. Normal size heart. Aortic arch and mediastinal structures normal. There is a significant amount of diffuse infiltrates noted. DX, pulmonary edema.
Alexa, stop.
Thank you very much for using the lab results skill. Hope to hear from you soon.
You see, just one person means that machine learning at the edge is much more closer than you can think about it. And then those 3 cases, just 3 examples, because technically speaking, anything can be used for machine learning at the edge, because everything is physical. Think about self-driving cars, or smart agriculture, or smart cities. Technically, everything that is physical, you can use machine learning at the edge to provide automation. And I hope at this moment, we are starting getting excited about the possibilities, and then I'd like to show how two things works. Is it time for the rock and roll? Is the technology moment? Let's build it together, because we are all builders. So first, to build something, let's understand the major steps about machine learning. So first, you need data. Maybe it's your data, maybe it's data from someone else, but data is the core of machine learning. There's no magic. Second is algorithms. And those algorithms, some of them are running since 50s. They're some very, very old. The difference is now we have all the computer power to make it work. It's the biggest difference when we talk about machine learning. Then you have the model. And actually, model will be something that we talk a lot today. So the model is the result based on our data, based on your problem, and then after the model is the one that takes decisions about what should be done next. And the next one, it's probably when I spend most of my time, is inferences. Because inferences is when you take the model and you just push the model to the production. See, is when your final user starts to see the benefits of the machine learning, which is exactly like to explore with the edge. And I'd like to focus on it create some use case. I know that you are from different areas, maybe from healthcare, maybe from different agencies, but for the next 35 minutes, let's pretend that we are all responsible to organize national parks. So now our goal from now on is how to implement machine learning to improve people or citizens' experience. It's our goal from now. So, and I'd like to start with voice. Why voice? Because what our customers has been telling us is voice is just getting the primary interface for computing in general, because it's natural, you see? You don't need to go to keyboards, mouse, or touch screens to select something. Just say it, and you receive this answer as a result of your process. And in order to do so, I like to use Alexa, which is our voice digital assistant that helps you to accomplish things. Can be like things about entertainment, like play the music, or things about home automation, or about cars. because now Alexa is going to everywhere in terms of voice. But because it's a technical session, let's understand how Alexa works. I'd like to use a very simple example. And here we have our Alexa device available, and let's play it and see how it works. So, Alexa, what's the weather in Ottawa?
In Ottawa, Ontario, it's 12 degrees Celsius with cloudy skies. Tonight, you can look for showers, with a low of 5 degrees.
What happened now with this quick interaction? Because I'm pretty sure many people here has already done it. But what happened behind the scenes? So first, when you say, Alexa, don't listen to you all the time, start listening only and only when you invoke the wake word. Wake word by default is Alexa, but if you go to the mobile app, you are able to change it. When you start saying Alexa, Alexa start hearing what you're saying, and they activate what we call as a speech capture. So speech capture the information and send to the cloud. Actually, the information that you have about Alexa is not processing locally. It's sent to the cloud. When you send to the cloud, there's a layer we call a speech platform, receive those information in a format of utterance. So the next step is we call as ASR, or automatic speech recognition. So we identify or try to listen what the people say, basically converting voice into text. Is exactly the answer. So, but not because I'm hearing you means that I'm understanding what you're saying. And this responsibility is the next step that we call as a NLU, or Natural Language Understanding. NLU is responsible to understand, try to break the sentence in small tokens, to understand or try to get what you call as intention, that call as intent. So intent is the name of the mechanism that to capture what the command would you like to send to Alexa. But now, it's not because I understood what you said, means that I know how to do it. And the next step is the skill. A skill is where the magic happens. Because in the skill side is when you plug your business application to go to your legacy system, do whatever you want in terms of database or legacy, and send it back. As an answer, receive a text, and this text goes to the last step that you call a transform text to speech. So after text to speech, they send back to this platform, which send back to Alexa device. Every time that you have done something with Alexa is the flow that happens behind the scenes. And then you just hear the voice of Alexa there. The good thing, special thing about the government says to us, hey, but I don't want to be locked in to you. I want to have options, and it's totally fair. There's a reason to break this solution in two major blocks. The first is device. So the device we call as Amazon Echo, that has all the sensors or the microphones to capture the information that you're saying. And what you just found out is when you think about device, you can implement device in different ways. So in that case, you have different products or different devices to support different initiatives, like Echo Show, that you have a video as well, Echo Dot, and others. Because in that case, you want to combine voice as a primary interaction and video to get some additional information. But you know what? Sometimes you say, I don't want to use nothing from Amazon. I want to create my own environment using some device like Raspberry Pi, or do whatever you want. Can I do it? Yes, you can. So the example that I like the most is the one at the top, a children playing with the device that you have no idea that's not from Amazon because it's not, but everything was customized, built to play and work in the same way. If you go to the internet and play Alexa Raspberry Pi, there's many examples that show step by step how to do this kind of customization. Means that as a government institution or healthcare, education, you can decide between an Amazon Echo device or whatever device you want to implement those kinds of things. So behind the scenes, we have the Alexa service. And Alexa service is the software by itself that controls everything about the interaction. You have two major components. One is Alexa voice services that allows you to have integration with the system. And the second one is Alexa skills, which is actually we'll just develop. So behind the scenes, we have models or machine learning models like semi-supervised learning. That there's a link behind it. I will share the presentation with details about how it works in terms of models. But actually, for you, you don't need it. What you need to do is just code your skill. And you know, it's time to coding. It's time to develop your skill and see how it works. So the first thing you understand the nature of the text, the nature of the message. You remember, we start this section now talking about the national park. And what I like to do is ask to Alexa information about the park. And I start by the cost of the ticket. Let's do it together. So first, what I tell to Alexa, Alexa, ask national park the cost of the ticket. And as a result, you receive the price. Now let's go to my computer. Here is the Alexa developer console that you can just develop your interaction and then push this interaction to the edge. So as I said, we create what we call as skill. And when you create skill, you define what kind of skill you like to create. In this case, I'd like to create a skill for national park. What national park can do whatever you want for this business domain. So just understand this part as a business domain of this skill that I like to concentrate it. I have support for multiple languages, which include English and French, Canadian French included here. Because you can create like multimodal or multi-language skills. And then when you create skills, what you see is examples about how we can interact with the device. Would you like to just receive information, or would you like to have like a game, like question and answers, like an FAQ? We have different models that you can implement in your skill. But today, because I like to start from scratch, I will use no accelerators. I like to use starting from scratch in order to show you all the steps. So here we are, we have in a console, and the first part is the invocation. And invocation here is not the name of the component, like National Park. It's the way that you, as a customer, will talk with Alexa to get those results. So in that case, I just split it here, because when someone says National Park, I will invoke this skill. The next step is the intent. So I have the invocation here, and the intent or the intention that you'd like to use. And the intent should be about price. So I define here get ticket intent, which is exactly the same intent or the same function that I show you in the PowerPoint. I show you how to define the name of the intent. Now I need to define the structure of the interaction. So what the customer will say about it. So for example, what's the cost of the ticket? So it's the sentence that I'd like to capture as a part of the intent to show and execute something in my environment. So now I have those things set in my environment. What I need to do, save the model and build the model. That moment, what you just mentioned here, go to the part of, oops. Oh, I know why. Like maximum, yeah, because I set it didn't press. Now it works. So now we have the intention here. And then in that case, define what the cost, and I create the model. The model is exactly one that I mentioned before. That is the machine learning part that just add in a huge network of knowledge with everything that you see in Alexa. You just include one more skill in this knowledge. So I have this skill here, and what should I do next? I need to link my skill with my code. And how you do it? We have the endpoint configuration that basically shows you two options. First, you can plug your code and see this code as the link between the text and your legacy system, that you can just launch a server, expose an API using HTTPS in the cloud or not in the cloud. It's totally up to you. And then you have a Lambda, which is a service that you don't need to worry about managing servers or even scale those servers. You just scale as you need, as was mentioned in the presentation before mine when you think about serverless. I will pick the Lambda one because I don't want to worry about servers. I just want to have my service running. So I configure here. What I need to do is the link between my Lambda code and my function. Now is the time that I'm going to switch to the AWS cloud. So here we have not only the Lambda function, but all the environment available to connect to your databases or to connect with your ERP, CRMs, or whatever system you have to create this integration. So here with the AWS console, I just go to the Lambda part saying, okay, I'd like to create a function. And here, when you go to function, maybe you're wondering, okay, Alex, but I don't know, it's the first time that I coding using Alexa. Do you have some sample that might help me? And yes, we have. We have the session that you call as browser serverless app repository that shows you several functions. Today, about 440 functions that you can use and reuse not only to deploy your code, but also to learn how to write skills or how to write Lambda's code. I have one example here, the Alexa. It's the first one actually. The GitHub, because this code is available in the GitHub if you want to change. Actually, I will change, and I will deploy the code. So what I do here is just select one template. That's one example about Alexa. This template that I will just link with the communication that I mentioned before, and then I will have the full experience using Alexa services. Now, they are creating, and what happened behind the scenes? First, they deploy some components that you can choose between Java code or Python or Node.js to provide all the libraries that you need. And they actually add some functions about security. For example, if I connect a database, which database can I connect? So all those different security options you can define in these functions here. So here you can see create complete. I have my function working. And then what I'm doing now is just change the code. You can use whatever development tool you like. You can use Cloud9, is the browser, is a web development tool available in AWS, Visual Studio, Eclipse. You just choose one that you are more comfortable with. And now you have your code, and just go there and deploy your code. I will change here. Actually, in this moment, I use the browser. And here my code. So as part of the code here, the idea is not going to detail about the code, but show it that's not that hard to implement it. So the first point is when you receive a message, what you receive is what the name of intent which was captured from device. So imagine several interactions, and each time that you call a music or ask for a price or what time the park opens, they call different intent. And then this one is the one that you define as part of your code, which is not by coincidence, is the same one that I defined in the configuration from the console. I change here. And now what I'd like to do is just put a message, because that code I don't need. This one is the one that I need. Saying, thank you for using the service. Thanks for using it. The price is $9.50. I just create my first interaction, and they say, as a result of this message, I just send it back to Alexa device. And here, again, it's about coding. It's actually the same code that is available in most of the APIs. You just define what kind of integration you'd like to have. Perfect. Save here. And when I save, and now it's time to test, to see it really works. So the way that there's two options that I can test. I will just link my function to my Alexa skill. I will save, and now it's time to test. So as part of the test, Alexa Developer Console provides to you an environment that you can test without buying any kind of device. Means that you don't need to have Alexa device if you want to start developing something. You just need to go to the tool and start to use in development by your own. And here I put the message, the test, Alexa, ask National Park the cost of the ticket, which was exactly what I mentioned before. And as a result,
price is $9.50.
Yeah, they said it again. Or better, I use Alexa to test it. Alexa, ask National Park the cost of the ticket.
Thanks for using it. The price is $9.50.
Here we are, like 50 minutes. So from the scratch, pass the code, link the skills, and deploy it in the device. Think about the possibilities that you can do use this kind of technology. Great. Let's going back to the slides. And again, Lambda is the one option that you can use. Why? Because you don't need to worry about if Linux or Windows, you just use the function, and the function just works. But I'd like to cover now computer vision, because computer vision is such an important area when you think about machine learning. And in order to understand better computer vision, I'd like to show you a video. So it's one example about a video that you have in the house, and the machine learning is just capture what happens in the environment. Identify objects, identify people, identifying actions. So all those things are possibilities that you can use in your machine learning model. And let's do something similar that I did before, but now with visual focus. But now I'd like to do something different, because the Alexa device, let me put a mute here. Alexa device needs internet. Means that without the internet, there's no way to have this device working. But not all the environments has internet available. Can I do something different? Yes, you can. So it's exactly what we are doing now. So in that case, I will do something different. Instead of training the model and running the model on the cloud, what I do is take the model, train the model in the cloud, and then push the model to the device. So what I did before is I just create a model using computer vision and deploy it in this device. So as part of it, the device with or without the internet will choose if I want to send them information back to the cloud or not. So you have autonomy on what you can run locally. In terms of developing the model, we highly recommend you keep in use the cloud because sometimes you need to use tools that help you in all the automation process. In Amazon, we have services like SageMaker, which was mentioned today during the keynote, or services like Deep Learning, AMI, that you have access to the low-level infrastructure to create your model. And behind the scene, you have all the physical infrastructure using servers based on Intel, for example, with C5, or even servers using GPU, using things like Tesla V100. Are all the options that can use in terms of create the cloud. When you think about image, we have several algorithms that you can use. One of the probably most famous one is the convolutional layer, that you just break the image in small chunks or small fractions to help you to understand first the basic or primitive lines, then after that, the combination of the objects, and then in the end, the object or the image by itself. In terms of code, it's just about a few lines of code, and here's the one example that you can define your strategy of learning. So how would you like to learn, or what's the best way to create your learning? And there's several tutorials that shows details about it. In the end of the presentation, I will make the link available for you to run the same demo that I used today. And then device, because the presentation today is about device. So the device that we're using here is that one is Deep Lens. Deep Lens is like a container that provides you capture the image and then run your code. And when you think about run your code, there's two major components of your code. First is, don't change. Go back to the slides, please. Thank you. And then when you have the plans, you have the Lambda code. Oh, wait. It's the same Lambda code that we developed before? Yes, it is. Instead of using voice, you can use computer vision. You can reuse those kind of things. And then the model that you create in AWS and push it to your environment. Let's see it. Let's build it together. Now, going back to my computer. So I will go back to the AWS console, and then what I will do now is see the package that I can deploy my code. In this second example, remember, we're talking about the national park. What I'd like to create is like a computer vision algorithm to identify birds. And I like this example. You know what? Because when I look at a bird, I know it's a bird, but I don't know exactly what species of that. Maybe one or another maybe knows it, but when most of people don't know. And what about using machine learning to identify it? Let's do it together. So in order to do so, I will create a project. And I create a project. There are several templates that you can use as well. I will create one blank. And as a template, I'll define first my project, Ottawa. First, what the model that I'd like to have. And this model can implement several frameworks like TensorFlow or MXNet. So you can choose the one that fits better for your computer vision problem. I have one here is about bird, I have faces as well, object. I just organize my libraries. You can import yours as well. And then you define what the function that you like to use. The function that's available in my repository is a bird detection. What this function will do basically is invoke the model sending the image which was detected. Create here, just in a couple of clicks, you just create this environment. And then as a last step, because today is all about devices, you just say, hey, Ottawa Summit, I want to deploy in the fleet of devices that I have. So in that case, I have one device, which is that one, but I can pick the one that makes more sense and choose what I need in terms of implementation. In that case, take about 3 to 4 minutes to deploy. I have already deployed this one before, so it's time to see it running. Now, what I'm connecting now is not the cloud anymore. I'm connecting my local device. And here, what I have here is the image captured in real time. If I put like my face, nothing shows there. Why? Because they say, no, I don't want to recognize face. Oops. Yeah, it is the delay. Here we are. Nothing there, but when I put the bird, small delay. Here we are. You see indigo, built-in, and the percentage is 25, 15%. Why? Because the machine say, hey, I think it's a bird, but I'm not sure. Which makes sense because it's not a real bird. If you put a bird, actually I did the test, it's available on the internet, you see like the percentage go to 80%, 90%. So now I will show you something that you can implement that really can provide intelligence and automation and performance to the people. In that case, my database has about 200 different bird species. Think about the possibilities. It's all about the session today. So now we have the bird. We have machine learning at the edge. If you want to implement something like, hey, I want to take this image and just move to the internet, you are more than welcome to do so. Super. Let's keep going. Go back to the slides, please. We cover computer vision, we cover natural language, and the good point is like the previous one with Alexa, you don't necessarily need to implement using Amazon hardware. You can implement by your own. And depends on the capability, you have some result like that. This one was taken in one of our summits. And then look the amount of people that this little device was able to capture in terms of people. Look the potential of the possibilities in terms of computer vision. And then when you think about extending or using a non-Amazon hardware, what happens behind the scenes? We have a service that we call a green grass, which works like an environment that you can deploy your model and deploy your Lambda code. So instead of worry about all the configurations in the device, you just have device there, deploy our code, and you have everything running. Exactly the way that I just did before. Because inside my deep lens camera, I have a green grass environment. And now how it works, or how it worked before, I trained my model, use SageMaker. With my model, I developed my code with Lambda. I push both my model and my code using Greengrass to the device, and the device took the action based on the model that was trained before, and then run it back and send the information back to the cloud. So exactly how it works in terms of architecture. One more point about computer vision before I go into the last step is about compiling the code. And one thing that I highly recommend you, if you want to have projects in an edge, is compile the code based on device, because edge is all about device. It's not that easy compile or optimize the code for every single device. Thinking about it, Amazon deploy Amazon SageMaker Neo that helps you in this journey. So just need to provide your model, and they optimize specific for your model. For example, NVIDIA Jetson is one of the possibilities getting more and more popular. Or Raspberry Pi is another option. Or even the Deep Lens are options you can choose and deploy it. The good news is Amazon SageMaker Neo is free. Like, it's an open source code actually. So you just use and try and see if you like. There's no commitment available required for SageMaker Neo. And now, going to the last step, because the question is, okay, if I have movement, if I have movement in my object, so how can I deal with that? So we have the model, and some important aspects of the architecture is the agent that is physically deploy the hardware, that to deploy your code. We need to think about the environment, because the one thing can create something in movement that works in a closed space. Another thing, like a robot, like those two. We have two robots here. Aaron is there. He showed the presentation, a keynote. He developed one. You see, it works in a beach. Another thing is working something that works in an open space. You see, let me just open here. Is the one that I will demo very, very soon. Let's see different kinds of codes, because you can customize based on your needs. Robotics is much more close than you can think about it. It's much more close. It's just happening. And then exactly what I would like to show now. So when I show those things, we have the environment, you have the state, that basically when I do something or the robot does something, and remember, I'm talking about autonomous robot. Okay, what scenario that I have now? Can I jump here or not? It's my state. I have things like action. When I see the scenario, what I'd like to do next. Or the reward. Reward is such an important aspect in machine learning, which means that if I do it right, I want to do it more. See, like a dog. Like this reward, which is a key aspect of the machine learning for robots specifically. Like a dog, like you just train your model, and train your model saying, hey, I want to penalize you when you do something wrong. I like you give extra points and do something right. And then over time, your robot, your device, just get better and better. In order to show it, I like to work with our Deep Racer, which is our device that helps you to learn techniques like reinforcement learning, which is exactly going this point. So what you have here is a device based on Intel Atom processor, which is device here in my hand. I just turn device now. A lot of buttons to yes, now. You say small sound. Perfect. It's the same that you have there. So the idea is I will deploy a model here, and they will just go and explore my environment, is the idea. Because imagine that I am in a national park. Now I have voice support for people know the price. I have cameras that notify the birds, and then I have robots to go and check the place, or like Erin did, some robots to clean the place. You see? Clean something that gets old very, very soon. The possibilities are endless. Now just go back to the slide, please. Let's build it together. Let's do it together. Yes. So here we have Deep Racer is a service in AWS. So here the reinforcement learning uses algorithms. As you can see, I have a couple of algorithms that I trained here. So what I do is create a model. Wait. It's the same that you saw before. Yeah, I'm repeating the same thing over and over again. Because when you think about machine learning, it's all about the model. When I create the model here, and this model is specialized in this kind of robot, or this kind of agent, what you need to do is, okay, what's the name of my model? Ottawa Demo 10. And picture this one I don't have. So because this model is the one that go around the place, I have the option of the tracks. What kind of track I'd like to use? Just to remind you, I'm using here because I use a pre-built track, but I'm able to customize this track entirely. The actions of my robot, like I'd like to change at 30 degrees or 20 degrees change. How is the steering angle? You see, I'm just adding options in my robot. Or the speed that I like to have. And here, just creating the action list with all the possibilities about my robot, actually. So have the code? Yes, code again. If you like Python, is a great language to learn. So it's my reinforcement learning that identify when I should penalize or not. So in that case here, I have different strategies that I can implement, like should follow the line, or try to see, or try to be inside the borders, or try to do something different. You just can choose the best strategy for your code. I use this one. The time of learning, because remember, the computer not just go and do things. Doesn't work that way. We need to train it earlier. So exactly what I do now. I train it. Let's say I train for 60 minutes. And behind the scenes, the process to train start to happen. Because basically, you just take the environment, put your simulator, and start to see things running. This one you take about 6 minutes to start training, but actually I had one that it was training before. It's here. Train, yes, demo Ottawa one. And here is exactly what's happened now. So you see that the robot is going. Let me refresh. And then I'm not running the physical environment. I'm running under the simulator. And behind the scenes, we have a new server that I mentioned so about RoboMaker that you can build and customize this environment. Let's go there a little bit just to show you what's happening. And then going there. So it's the environment of robot, and maybe we were wondering, hey Alex, I got lost. Because it sounds like you are on the same screen. Yeah, because everything is integrated. Doesn't matter if machine learning or robot, you see, it's different service with different configurations. Now in the service of RoboMaker, you see the screen a little bit different. And then in terms of simulator, we use open source called Gazebo. And then in Gazebo is the area that you are able to customize your track, your environment, and it's exactly what's happening now. My robot is training in the track that they find. So if I have like a robotic arm, or like to put trees in the middle, it's just play all day long, create the environment that I like to simulate, and based on the environment, your machine learning model will learn. It's how it works. Great. Now it's time to see the robot running. Going there. Jeep Eraser console. Now if you wanna, yeah, I think it's better keeping my computer instead of changing to the robot. So I have the camera here, the controls. In this case, because robots and machine learning, they can work together or not, we have options to say, I would like to have a manual driving, just to explore the robot features, but I like to jump directly to the autonomous driving, which is the link between machine learning and robots. You can choose the model that you have. The one that I just showed you before is this one, Ottawa National Park, and then I load the model. And then as part of the load the model, I say, okay, load the model, and then I just push the code which was trained before. It's not the same one that I click. It's just the result after an hour of this model. And I push this model to where? I push the model to the device. So it means that you can push as much models you want, and just to see what's the best configuration for you. The model is done. So here we have the screen. Now if you change the camera to the device, a great thank you. And now it's time to run the device. So here you start. Here we are. Nobody's driving. Just explore the environment. You see? And then, depends on the training, it just explore things over and over again, then combine things. And again, we are not tied to this specific device. You can literally build whatever your imagination think that make sense. It's the power of the cloud. It's the power of robots. It's the power of machine learning. Machine learning to do good things like clean beaches. Just have a better world. Going back to the slides, please. Here the architecture before. I remind you that we receive all these slides available very, very soon that you can check it again. So the architecture is SageMaker as our machine learning model and RoboMaker, which deploy the code there. RoboMaker as a service by itself, you can implement as many automations as you want using methods like publish, subscribe to provide a full integration, not only in terms of actions, but in terms of management. Because you know, managing like 2, 3 robots is completely different than managing like 100 or 1,000. And all the infrastructure is available using RoboMaker. And then my last 2 slides, I think there's no better moment to work in a public sector, healthcare, education, and no-profit organizations, because you cannot be the spectators. You must be the actors of the future. The sentence is not mine, I wish it was, but it's for Herb Simon, that for me reflects exactly the moment of working in a public sector. You see, we have such a great opportunity, literally, to change the society. And I'm pretty sure that machine learning and robotics is an area that provides this change. So this last slide, if you want to know more about everything that I did so far, ml.aws, in ml.aws, you'll be able to see demos and recipes and everything that I did so far, step by step. There's also a machine learning university with several free courses that you can attend if machine learning is something new for you, that helps you to learn fast and try to deploy things similar. My Twitter, if you want to follow me to know more about cloud, machine learning, robots, you are more than welcome to do so. That said, thank you so much. I really appreciate the time with you here and the network reception. Thank you. I will be around.